All right, did that fix it? What the heck? I am so sorry, everyone. I don't know what Zoom did, but it had everything blocked. Okay, so the good thing is I always keep these the MDEs a little shorter, so it's just going to end at the normal time now. But we'll go ahead and do what we were going to do, or do what should have been going on for the past 15 minutes that y'all couldn't see apparently, talking about the stuff from chapter 4.1 that we were working on earlier. So give me a second to set that up.
Absolutely. If I'm going this way, it's twice to the right. If I'm going this way, it's twice to the left. I like little tricks to help me remember things. So I said that a percent number should always look bigger than its decimal equivalent. So that way, if you have something like 0.75 as a decimal, when you convert it, it's either going to be 0.0075 or it would just be 75 as a percent. And you go, well, is it supposed to be 75% or 0.0075%? Well, Mr. Beckner said the percent number should look bigger, so it's definitely the 75% then. That would be a great way to remember things. It's worked for me for a long, long time. All right, then we said if we're converting from a fraction to a percent, this you should do the division of the fraction, and you don't have to worry about the long division because we are allowed calculators. And then you'll move the decimal twice to the right, just like the straight up decimal to percent conversion. Or if you ever have to go from a decimal to a fraction, the number of decimal places is how many zeros you need in the denominator. So if there's one decimal, then you need a 10 in the bottom. If there's two decimals, then you need a 100 in the bottom. If there's three decimals, you need 1,000 in the bottom, et cetera, et cetera, et cetera. And of course, you always have to make sure you're reducing your fractions as much as possible. Now, what about if I asked you to convert a percent to a fraction? Well, you go from a percent to a decimal by moving the decimal place, and then you do the thing I just said. So there's always a way to get from one of these three things to the other one, whatever you're supposed to be getting to. So again, what I would like to do for us, what I would like y'all to work on at first, where did it go, is this guided activity from page 158. So we started doing number 2 in class, but we're going back to number 1. So we're going to do this, and we're just going to fill in the table. Notice that the numerals in the first column are the numerators in the fractions. So in other words, this 75%, the 75 goes here, and it's 0.75 as a decimal. So they give you an example of just 3 that are, and they don't show you the work for it, but they just give you 3 that are connected. 75% is 75 over 100 is 0.75. But the theory is you could start with any of these 3 things and get the other 2. So what we want to do is exactly that. We're going to be given one of these things. Now we got some people coming in. Or nope, someone left actually. We're given one of these things for each row, except for this one down here, which is going to be 200 over 100. Yes, 200 over 100. 200 over 100. So that is the fraction. It's a very weird fraction, I know, but that's the one they give you. So it's not reduced, but nor was this one. So don't focus too much on reducing the fractions. Just focus on converting them to a fraction. In fact, let's focus on converting them to just a fraction where the denominator is 100. And if you have anything else that works, that's okay too. So our goal is to get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 answers. I will do with you the first 2. We'll do these together, and then I'm going to let y'all work on the rest. So I'll give you maybe 5 minutes to work on a pair, and then I'll go over them, 5 minutes to work on a pair, then I'll go over them, that kind of thing. All right. So we have 0.75 over 100. So again, 0.75 over 100, this is actually a really bad fractional form. because of the fact that you have a decimal inside of a fraction. This is a horrible way to answer things as a fraction, but sometimes in the real world, we're given numbers in a horrible format. So you would never ever answer anything that way, but it's given to us that way, so we just got to put up with it. So going from fraction to percent, if the denominator is 100, this is actually really easy. You can see that when the denominator was 100, the 75, the top, is just what is in front of the percent symbol. So that means if this is a 0.75 over 100, you can make it really easy and just say, oh, well, that's 0.75 since the denominator is 100. It's every one thing to 100 of them as a fraction, as a percent, 0.75 per 100. Don't forget your percent symbol, like I almost did. The decimal, well, you can take the percent number and you can just move its decimal twice to the left or right. If you think it's right, I'm pulling out the red for wrong for a second. That would say that 0.75% is 75, but remember the percent should always look bigger and the decimal should always look smaller. So that can't be right. It must not be 75. Oh, I erased too much. I knew that was going to happen. That's okay. I know I clicked it. So we don't go right. We know we're going to go left twice, which is going to end up putting a filler zero in place. So it's going to be, excuse me, two filler zeros, 0.0075 as a decimal. Again, this problem, all of these fractions are going to be focused with denominators of 100. In reality, your goal would be to reduce them. So that's just kind of a little quirk about this. All right, so let's try out the third row with the second one to actually work on. 7.5 is a decimal. To convert it to a percentage, you're just going to move the decimal either left or right. If you move it left twice, that would make it smaller, but the percentage is supposed to look bigger. So we're supposed to go to the right twice, which would end up putting one single filler zero. So that would become 750. And I love these first three examples because they just show you different 75 numbers. 75 as a whole, 0.75 as a percent, 750 as a percent, but it's all sevens and fives. So you can get a gauge of how these are sized. All right, so what about the fraction form? Well, you could, again, normally what I would say is I would look at the decimal number and I'd say that there's one decimal place. So that tells me the bottom should be a 10. This is how I would normally do things. And then the top would just be this number without the decimal, which would be a 75. Now, that's a perfectly valid fraction answer. And in fact, I would even want it reduced. 5 goes into both of those, so you'd end up with 15 over 2 specifically. But since they're kind of starting these things with all over 100s again, let's just try and go with that idea. So while 75 over 10 is a good answer, what I'm going to do is I'm going to say, all right, well, let's look at the pattern here. This, when that was a 75, that made the top a 75. When this was a 0.75, that made the top a 0.75. So if this is a 750, that makes this a 750 over 100. Again, the percent number, if you have a percent number, you can literally just slap it over 100 and you're done. Again, in terms of writing it as a fraction, you should really reduce in general, which again would have ended up being 15 halves, but we're just not focusing on that side of things for here. So I've done the first two. Again, I'm going to go over these in pairs. If you knock out all 6 rows of this in 5 minutes, then you'll just have to be patient with the rest. So I'm trying to move something. Okay, so what I will do is I'll give you about 5 minutes to work on these. So you got 4 answers to get, trying to base it off of what we've already done. Again, percentage to decimal is pretty easy. It's just move the decimal twice left or right. And then going between percents and fractions, it's just the top of the fraction is the percent, or the percent is the top of the fraction with a denominator of 100. All right, I'm gonna start the clock with 5 minutes. We'll go over them after that. All right, so let's try these out. So 4.5%, again, the kind of clue I was giving you to go between percentages and fractions over 100 is the 4.5 is just the top. Again, this is not a traditional way I would ever want to write a fraction. It's just how they're doing it for this exercise. And then the decimal value to go from 4.5%, you just move the decimal left twice, and you should get 0.045. Again, this fraction part, what I would really, again, in the course, in Math 154, you would never have 4.5 over 100 as an answer. What I would have preferred was you take the decimal value, the 0.045, and you say there's 3 decimals there. So you write the 45 in the top and a 1 with 3 zeros in the bottom, and then you would just reduce, which ends up 5 goes into 45 9 times, and into 1,000 200 times, and that would be the fraction answer in reality. This is what should be here. Again, for the point of this exercise, though, we're just trying something a little different. Then for the next row, we've got 275 over 100. All right, well, since that denominator is 100, we can go straight to a percentage. It's 275%. And then we can take the decimal, which is after the 5, move it left twice, and you would get 2.75 as a decimal value. Again, this 275 over 100 is never going to be an acceptable answer in this course. You would have to divide it by 5 and anything else and reduce it as much as possible. All right, so with that in mind, let's try out the next two. So we're going to take 5 minutes, and we're going to try out to get those 4 blocks. Make sure you notice there is a negative with the 0.0023, which means there should be negatives for the fraction and percent answers. All right, so we'll give you another 5 minutes to try those. All right, so let's try this out. So we got this negative. I'm just going to go ahead and put the negative in all of these so we can't forget them. And to go to decimal to percent, from decimal to percent, it's moving the decimal twice. It's either left or right. If you move it left, you're going to keep making that number smaller, but the percentages are supposed to look bigger. So we are going to move it right twice, which will end up with a 0.23, so negative 0.23%. Then, looking at the percentage value of negative 0.23, since we're specifically trying to make fractions over 100, again, not the norm, we just write the 0.23 in the top. 100% by definition is literally 1. If you move its decimal left twice, you can see that. And as a fraction, if you want the denominator to be 100, the top is definitely 100. But I know that all of you know that that should really be a 1. That 100 over 100 is really a 1. So the fraction and the decimal number are exactly the same this time because the fraction reduces to a whole. All right. So I want to get to the next set of problems, so I'm going to go ahead and do these with y'all. So that 200 over 100, again, which is really a 2, well, I mean, that exactly tells you what it is as a decimal. It's 2. 200 divided by 100 is 2. Did you have to do it that way? No. There are lots of different ways to go between column to column. I'm just trying to give you some of them. And if you have a denominator of 100, that makes the percentage just whatever the top is. So it's 200%. Again, yes, this answer in the middle for this class should really be a 2, but we're just going with the flow for now. 3 has its decimal originally here. To go to a percent, you got to make it look bigger so the decimal goes right. 2 filler zeros will make that a 300%. And then if you wanted to write that as a fraction over 100, you just write the percent number in the top. So 300 over 100, again, which is technically 3. Y'all get the point. So again, this skill of going between decimals, that's not what I wanted. That was the wrong color. This skill of going between, it doesn't work really great either. I want something, I'll just go back to red. Decimals and percentages. This is where our bread and butter is in QR. This is what we see most of the time because we try and do things like they'd be in the real world. And when you go and apply for a credit card loan, they don't give you your APR as a fraction. They give it to you as a percentage. But when you want to crunch numbers with it, you'll need to convert it to a decimal. Yes, you could convert it to a fraction, but nobody converts it to a fraction. So again, these are the two that we're going to be bridging the most throughout this course. So if you struggle with the fraction part, it's most likely not going to harm you too much, but it is still a skill that I would hope you sharpen by practicing, and then practicing some more. All right, so we're going to clear our screen, come off of annotate. That'll be it from this file. So now what we're going to do is I'm going to do some more examples like I was doing in my QR class today, where I give you some real world contextual problem and you've got to find the missing value, whether it's a percent, a part, or a whole. So as a reminder from our chapter 4 notes, the way I am going to be setting everything up in this course is this way, but I did mention if you know some alternative method like being able to use y equals kx because it's a proportion, so you could, or using a proportion table, creating one of those because you could, they're all linked together. I don't care how you get the job done, but I will be instructing in this manner. I also gave you the fact that is means equals, of also means what or what number, of means times, what or what number means x or p. If you have what percent, it's p specifically. And then you can make a linear equation out of it instead of a proportion and solve that. And it's no more complicated, it's just a different style of things. And since we are focusing so much on proportions, we choose to emphasize this style. So part goes in the top, whole goes in the bottom, and then it's percent over 100. We're just scaling some part to whole relationship to 100. The portion of people who are numerate are numerate enough at math to work in a car factory out of all of them? You know, something like that. We talked about way back in the beginning of the semester. Okay, so part over whole equals percent over 100. Part over whole equals the percent value over 100. Now remember, don't convert the percent to a decimal, because when you have it as a fraction, it's already counting as a decimal. Fractions are decimals. In fact, the name of decimals is technically decimal fractions. All right, so let's say, let's go with what we were just talking about, since it related to a much earlier problem, like 7 to 8 weeks ago. Let's say 35% of people in a certain state are numerate enough to work in a car factory. I gotta do some little light programming of things to get the cars built, whatever. If the state has a population of, let's go, 10.5 million people, how many people work in a car factory? It'll be our first example, and we're going to do this one together. So I'm going to do one with you, and then I'm going to set up another one and give you some time to work on, and then we'll go over it. So 35% of people from a certain state are numerate enough to work in a car factory. If the state has a population of 10.5 million people, how many people could work in that car factory? So we have things with percentages and a part and a whole. So we're going to do this fraction equals fraction. Fraction equals fraction, where one of the denominators is 100, and that is us scaling the whole to 100. We've talked about how we don't have to scale something to 100 necessarily. We can scale it to 1,000, we can scale it to 10, we can scale it to 17 if we wanted to, but we're scaling it to 100 to call it a percent. Now we're scaling the whole to the percentage value. What we're going to learn in a later section is you can scale the part to 100 instead, and it seems weird, but you can. All right, so what else goes where? Well, the 35% has to go with the 100, and if you do this, 0.35, that would be wrong. Well, yes, 35% is 0.35 as a decimal, but it's also 35 over 100 as a fraction. So when you just write, oh, I don't want to do it that way. So the 0.35 was wrong. This is really 35. That is why I was just practicing us writing percentage numbers as something over 100, because when you do this part to whole equals percent over 100, it's pretty common, and it gets you used to seeing that, oh, the percentage value is just the top of a fraction if the bottom's 100. That's why we did that. So the question we're having to ask ourselves now is, this 10.5 million people, is that the top or is it the bottom? Where does it go? Is it the part or is it the whole? So you got to say, is this part of the state population or is it all of the state population? Well, the state has a population of 10.5 million people. So that is the whole. It's 35% of these people that can work in this car factory. So that would be the part. So the 10.5 million people goes in the bottom, and we generally don't write our units when we write proportions, so we just have to remember that these are in millions of people. Then the top, we have no idea what it is, so that's our X. I don't know why I have that in a different color. That's silly. And there we go. So we cross multiply, which says we take the 100 times the X equals to the 10.5 times the 35. We're going to pull out our calculator to do that. Save ourselves some time. 10.5 times 35. And we get 367.5. So our, oops. Please grab that. Thank you. Why is that not going all the way across? Oh, that's why. Okay. So the 10.5 times the 35 was the 367. 0.5. And then we just divide both sides by the 100. Which dividing by 100 just takes a decimal and moves it left that number of times the number of zeros. But if you don't like memorizing little tricks like that, show your division, divide it correctly, and you get 3.675. So we get x equals 3.675. And someone will go, well, there's my answer. Nope, that's not the answer. That's not the answer for a couple reasons. First of all, you have no units. Second of all, you're not telling me at all what x relates to. And third of all, there's an even bigger issue. All right, so we're talking about people, so someone might then go say, all right, well, this is people. This is still wrong, because it's not 3.675 people or 3 people or 4 people, depending on how you want to round. The number for the people, for the whole we were given was in millions, which means this is also in millions. So it's 3.675 million people are numerate enough to work in that car factory. Okay. So I want you to try this one. 2% of observed rainbows are known as double rainbows. What does it mean? Sorry, I had to. So what that means is you have your first bow with your blue and your reds and all that stuff. And then you have some, it kind of looks like shaded region here. And then you have another rainbow up here and it goes red and then up to blue, Roy G. Biv, all that stuff. And this shaded region between it's called Alexander's dark band. Not that you need to know that. That's not quantitative reasoning. I just love what we call math and nature, optic stuff. But anyways, so that's a double rainbow, too far. Instead of just one, it's 2. So 2% of observed rainbows are known as double rainbows, and you might not see the whole second one, but part of the second one can at least be seen. So if someone observes, let's go with 150 rainbows, how many do they expect to be double rainbows? So you're going to take 5 minutes and try that out. And then we'll go over it. And when I have y'all doing this, y'all can, in the chat, y'all can post the answer. And I prefer if you posted it to me privately, and then I can respond whether you're right or wrong. I have no problem doing that if you want to actually know. And that way, if you got it wrong, then you can try again. But you can also post it publicly. I'm not going to say don't do that. It's just maybe you want it to be private. That's your call. All right, 5 minutes. All right, let's try it out. So 2% of observed rainbows are double rainbows. If someone observes 150 rainbows, maybe over their life, that's a lot of rainbows to see. How many do they expect to be double rainbows? Well, sounds like a part to a whole relationship here. It sounds like we have a part or a whole and we're looking for a part of a whole, and we're given a percentage, so we should probably go proportion scaled to 100. The percentage is what goes in the top. This is not 0.2 or 0.02, it is 2. Remember, the percent is the same number on top of 100 as a fraction. Someone observes 150 rainbows. How many do they expect to be double rainbows? I'm going to do this wrong first. I'm going to do this wrong first intentionally. So I think the 150 is the part. So I got my red for wrong. So I think this is 150, which means this is my x. And when you cross multiply, you'll get 150 times 100, we'll just put 2 more zeros on the 150. And then the 2 times the x. And then when you divide both sides by the number with the variable, which is the 2, you're going to get, that was 15,000, so 7,500. So what is x? X was the number of double rainbows, so it's 7,500 DBL rainbows. Does that make sense? No. If they saw 150 rainbows, why would they expect 7,500 of them to be double rainbows? At most, 150 of them would be double rainbows, and that's if you were just the most lucky person in the whole wide world. But you're expecting only 2% of them to be that, which would be a much smaller number than the 150. And that's because we misidentified the 150 as a part when it was actually a whole. That was supposed to be the whole, which means the 150 was supposed to go there. So let's set this up the right way now. Colon, not question mark. It should be x over 150, part to whole, the 150 is all the rainbows, equals the 2% of them. Cross multiply. 2 times 150 is going to be 300. So you get 300 is equal to 100 times x is 100x. You're going to divide both sides by 100. 300 divided by 100 is 3. So 3 is equal to x. So it means you'd expect 3 double rainbows. That makes sense. If you see 150 and it's a very small chance that any of them are double rainbows, yeah, you're probably only going to see 2 or 3 or 4 of them. And specifically it is 3. Again, that's if expectations meet statistics, which in reality we know that doesn't always happen. Maybe someone sees 150 rainbows and they actually end up seeing 20 double rainbows, or maybe they see 15, or maybe they don't see any. Expectations versus reality. I mean, that's just the name of 2020, right? But that's why I use the word expect there. All right. Virginia sports ballers end up winning 75, excuse me, not 75, 70, no, yeah, 75, that was right, 75 of their matches over the season. They won 60% of their matches. How many matches they have? So clearly this is our tennis skitball team. They won 75 games and they won 60% of their games. How many matches did they have though? So you've got to say, all right, we got our 60%, that's obvious where that should go, but the 75, is that the part or is it the whole? Where does it go in that fraction? And then when you get your answer, you're going to ask yourself, does it make sense That way, if you have it wrong, you'll probably say, oh, I must have just put it in the part when it was a whole, or I put it in the whole when it was a part. You're cross multiplying again, and hopefully you'd have a much better answer. Another possibility is that percentage, the 60%, if you write it as 0.6, that would be wrong. It's 60 over 100. All right, so I'm going to give you maybe like 3 minutes for this one, since we're getting in the groove of things, 3 or 4 minutes, and go. All right, so same idea, fraction equal fraction, talking about percent, so one of the bottoms has got to be 100, the percentage is 60%, so the 60 goes there. So the sports ballers ended up winning, sounds like the Washington football team, right? End up winning 75 of their matches over the season. How many matches did they win? So the question you're asking is the 75 the part, or is it the whole? Well, they won 75 matches. Does that say that they played 75 matches total? Well, no. If they only won 60% of them, they had to have played more than 75 matches. So that can't be the part. I'm sorry, I said that wrong because I was trying to scratch out the whole when I'm looking at that. It can't be the whole, it has to be the part, because they are going to have played more games if they won 75, but they only won less than 100% of them. So the 75 should be the part, making it go in the top. Another way you can tell that it's the part is because anything that comes after of is the whole. So here's the word of, so the next thing would be the whole, and that's their matches. 75 is not the number of matches, that was the number of winning matches, a smaller portion of the matches. That's why we call it a part versus a whole. All right, so that makes the bottom an X. We're going to cross multiply, and we'll get 7,500 is equal to 60x. We're going to then divide both sides by 60 to finish this off. And we will end up with x is equal to, we got 7,500 divided by 60. And that's going to be 125. Hold on one second. All right, sorry about that. So 125, but again, 125 what? 125 is not a quantitative reasoning student answer. How many matches did they have? They had 125 matches or games, events, whatever you want to call it, as long as you don't just say 125, because then I'm going to come in and be silly and say 125 oranges, 125 bobs, 125 trailers full of destructed tile that's being towed away from my house right now, and that's why I had to pause. All right. Let's do one more, and then we're going to call it a day. And I just lost my numbers. I got distracted because things are going on at my house. Sorry, real world. I know y'all understand. I wish it wasn't like that. All right, last example. Let's say the Earth makes up 0.5% mass of the planets in our solar system. The mass of all planets is, I'm sorry, you got to hold on a second. Give me 30 seconds. There we go. Okay. If the mass of all planets is, let's go, it's we'll do it this way to keep your side easier. 1320 sextillion tons. What is the mass? Okay, this percentage is not accurate, and this number isn't accurate, but the Earth mass will be accurate when we get it. So septillion tons would be 1,000 sextillion tons. So it's millions, billions, trillions, quintillions, quartillions, sextillions, then septillions. All right, so we have the mass of all planets, 1320 sextillion tons. So again, that's just a mass, and a ton is a mass, not a weight, because that's that British system we've talked about, not the standard American system we like. We got our percentage, so we're going to go 0.5 over 100, not 0.005, not 50, 0.5 over 100. Then we just got to ask, is this the part or the whole? Well, we said the mass of all planets, all means it must be the whole. So that number is going to go in the bottom. We don't need all the extra ridiculous amount of zeros. So we just put 1320, which means our x goes up here. We're then going to cross multiply. So we take our 100 times our x. We take our 0.5 times our 1320. So we're going to do 0.5 times 1320, which is just half of 1320, and that's 660. And then we're going to divide both sides by 100. And that will give us our answer of x is equal to, well, anything divided by 100, again, just moves its decimal left twice. If you need to show the calculation, go for it. But that would be 6.60. But again, 6.60 is not our answer. That makes no sense in context. What are we talking about? Well, the mass of the planets was in sextillion suns, so the mass of the Earth should be in sextillion suns. Tons, not suns. 6.6 sextillion tons. And those are very, 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 very large masses. And we can't really say that they have weights because our weights are based on the planet's mass. There's lots of science behind that. We're not going to get into the gravitational pull between two objects. Some really cool physics there, but again, not for our class. So this is very, very, very applicable, especially some of the problems I did in the regular class too with the taxes. You can figure out, okay, well, I'm looking at my 1040 and I see what my net income is, I see what my gross income is. You can just divide those two things and boom, you've got the percentage of income that you actually kept. And then if you did 100 minus that, you'd figure out what percentage you paid. Or you could just add up all your tax and Social Security and med numbers, all that, and then divide that by your gross, and that would give you the taxes that you paid as a percentage. So really cool things that you can apply, a really simple basis of an idea, again, that we can expand upon and will expand upon. But we're going to call it a day for now.
All right. So again, I apologize for what happened at the beginning with my my Zoom controls being hidden there. I had no idea that the screen was paused and I couldn't see the chat, so I didn't know y'all were telling me. So that sucked. But we got it fixed sooner than later, thankfully, and we still managed to finish everything in time. So have a good one. Again, welcome back from spring break. Get as much homework done as you can over the next 2 days, and we'll see you on Wednesday the 16th. Take care, everybody.